all, welcome to your one and only lesson for this week. It's a really short week with MEA. If you haven't looked at the calendar already, we have this one lesson. You'll have a short quiz tomorrow on Tuesday, and then Wednesday's still going to be a work day. If you have questions about that schedule, please let me know. Another thing, if you haven't looked at the calendar yet, your next test is next week. I've already opened the Zoom section so that if you want to meet a little bit early so that we can talk about preparing for the test and exactly what's going to be on it, you can start having those meetings this week. Let us finish up with Chapter 2. We're going to do our last lesson in 2.9, so get yourself ready for notes. So this last one, we're going to talk about determining the functions of derivatives. So we've done a lot of graphing, but you can also find derivatives algebraically. And the idea is that we're going to start with this same function, this limit of f of x plus h minus f of x over h, which is the formula for the slope of the curve at that point. But the main difference is that instead of f of a, we're doing f of x. So we're just talking about it as a general function instead of at a single number. Now, in order to find the derivative function of x squared, we're going to start with this formula. We're going to say, all right, well, f prime of x, the derivative of f, is equal to this limit. Now, all we need to do is use our limit skills from earlier in this chapter, and we can solve this. So we'll say the limit as h approaches 0, f of x at this point is x squared, so x plus h squared minus x squared over h. We'll expand out that polynomial, x squared plus 2xh plus h squared minus x squared all over h. So this should feel, again, very similar. We're just using x instead of a when we have the subtraction. That cancels, and then we are left with terms that all have a common factor of h, so we can factor out one of those. Now we have a limit as h approaches 0 of 2x plus h. Now here's where we're going to be a little sneaky. This says that h is going to 0. So that means we're going to plug that in for h like we normally would. It doesn't say anything about x, so just leave x the way it is. We're only plugging in for h. So this becomes 2x plus 0. And we're left with f prime, the derivative, is 2x. So what that means is that at any point on here, the slope of that parabola is twice the x value. And what that means is that here we have a parabola. We drop down 1 degree in terms of our derivative. And this is just always going to be true, as I've said. So there's a pretty straightforward option. We're just going to use our same limit skills that we've been focusing on up till now. Let's look at a more challenging one where we've got a root involved instead of just a polynomial. So we're going to start the same way. Find the derivative function of f of x. So we're going to start the same way of saying, okay, well, f prime, the derivative, is equal to the limit as h approaches 0 of f of x plus h. So x plus h for that first term plus root x plus h, and then minus f of x, which would just be x plus root x, all over h. Now, as usual, the first thing we want to do is simplify that numerator with the subtraction. So we've got x plus h plus root x plus h minus x minus root x all over h. So the main thing that we can simplify here is the x. And unfortunately, we can't simplify the roots because the roots only simplify if they have the same thing on the inside. What we can do, though, and this is we can ask ourselves, oh, well, when we had fractions and limits before with roots, we used a conjugate. These two will be easy to find a conjugate for because there's roots and they're being subtracted. This h is kind of weird and annoying. Well, here's a nice trick. You can say, well, we've got as h approaches 0, we've got h over h plus, and I'll take the other fraction separately, root x plus h minus root x all over h. And this is great because h over h just becomes 1. And now we don't have to worry about any additional variables. So I'm going to multiply this fraction by the conjugate, so x plus h plus root x. Do it to both sides. Remember, the conjugate just means that I'm changing the sign in between. And when I FOIL out that numerator, we still got the 1 plus from here, we end up with x plus h minus x as we square both, and then the internal parts cancel out. And I'll leave this as h times root x plus h plus root x. Now our simplifying, the x's cancel out, as do the h's, leaving just 1 in the numerator as our limit as h approaches 0. So we end up with limit as h approaches 0 of 1 plus 1 over root x plus h plus root x. Again, it's as h approaches 0, so we're only going to substitute in for there. So this becomes 1 plus 1 over root x plus 0 plus root x, which is 1 plus 1 over root x plus root x. Root x plus root x is our like term, so we can do that to root 2x. So f prime of x is equal to 1 plus 1 over 2 root x. So that's a much more challenging version, but you'll notice that we're still using those same limit skills that we've been practicing all chapter. Please sign up for a Zoom meeting within the next 2 weeks so that we can prep for the test, and I'll talk to you later.